3 billion pieces every year, one of the most recognized chocolates on Earth. And almost nobody knows what actually goes inside one or how it's made. This is the full factory journey of Ferrero Rocher, from raw hazelnut to gold wrapper, and what happens inside is far more precise than anything you would expect. The process starts before a single machine is switched on, in the agricultural regions where everything begins. Ferrero is the single largest buyer of hazelnuts in the entire world, purchasing close to 25% of the global hazelnut supply every year. The primary sourcing regions are Turkey, which produces more hazelnuts than any other country on Earth, along with Italy, Chile, and Georgia. The nuts are harvested, dried, and transported to Ferrero's receiving facilities in large quantities, but arriving at the factory door does not mean they are ready to be used. Every incoming batch is held and tested before it moves anywhere in the production system. Quality control at this entry point covers moisture content, oil concentration, shell integrity, contamination screening, and flavor characteristics. The testing is not a formality. At the volume Ferrero operates, processing enough hazelnuts to fill an entire cargo ship multiple times over every single year. A single substandard batch entering the system early creates compounding problems across millions of finished units. The inspection exists to prevent that. Batches that pass move forward, batches that don't are rejected before they touch a single piece of production equipment. From the receiving and inspection area, the approved hazelnuts move into the roasting lines, and this is where the first major physical transformation of the entire process takes place. The nuts are fed into large industrial roasting drums, long rotating cylinders that tumble the hazelnuts continuously through carefully controlled heat. The variables inside these drums are not set casually. Temperature, airflow, drum rotation speed, and duration are all calibrated together to hit a very specific flavor development target. The chemistry of what happens inside a roasting drum is the reason Ferrero products taste the way they do. Heat drives moisture out of the nut, it breaks down certain compounds and builds others. The natural oils in the hazelnut migrate toward the surface. With the Maillard reaction, the same chemical process responsible for the crust on baked bread, generates hundreds of new aromatic compounds that didn't exist in the raw nut. Too much heat and those compounds tip into bitterness. Too little and the depth of flavor never arrives. The drum holds the nuts in the precise temperature window where the flavor becomes exactly what the recipe requires, and when the roasting cycle is complete, the nuts emerge a consistent deep golden brown, their skin splitting at the seams, the air in the roasting room carrying the full concentrated warmth of that smell. Toasty, sweet, rich, and unmistakably hazelnut. Immediately after roasting, the skins are removed. The freshly roasted hazelnuts pass through a skin removal system that uses a combination of mechanical friction and controlled airflow to strip the thin, papery outer skin away from the nut surface. The skins are dry and brittle after roasting and separate relatively easily, but at industrial scale, the system needs to work fast, continuously, and without damaging the nut underneath. After skin removal, the nuts pass through a cooling stage that brings their temperature down from roasting heat to a level safe for handling and further processing, a necessary step before the line diverges into the two separate directions that define what Ferrero Rocher structurally is. This is the point in the process that most people never think about, and it explains why the chocolate has the texture it does. At this divergence, the hazelnuts are sorted by size. A select portion, individual nuts that fall within a very tight diameter range, are separated from the rest and set aside completely. These are the whole hazelnuts. Each one will be placed individually at the geometric center of a finished Ferrero Rocher. They go into temperature-controlled holding at this stage, waiting for the moment later in the line when they will be needed. The remaining hazelnuts, the majority of the roasted skinned batch, move in a different direction entirely, toward the grinding and paste production area, where they will be transformed into something unrecognizable from their current form. The paste production process begins with pre-grinding, where the roasted hazelnuts are broken down into progressively smaller fragments in a series of mechanical crushing and milling steps. The goal is to reduce solid nut material into a fluid, pourable paste, something that requires taking the nut from a hard, discrete solid all the way down to particles small enough that the cell walls rupture and the natural oils are fully released. As the cell walls break open, those oils flood the mixture, and what was a dry, crumbly, granular material becomes increasingly fluid. With every pass through the mills, Sugar, cocoa powder, and skim milk powder are introduced into the mixture at specific points in this grinding sequence, blending with the hazelnut material as the particle size continues to decrease. The final milling stage brings the entire mixture down to a particle size of around 20 microns or smaller, finer than the human tongue can detect as individual particles. At that scale, what you experience when you eat it is not texture at all. It is smoothness, pure, uninterrupted smoothness. This paste, dark, dense, fluid, and intensely aromatic, is the hazelnut chocolate filling that forms 2 of the 5 structural layers in every finished Ferrero Rocher. It is held in temperature-controlled tanks, kept at the precise consistency required for the next stages of production, and drawn from continuously as the assembly line runs. With the filling produced and the whole hazelnuts prepared, the production system now moves into the most structurally complex part of the entire process, and the part that makes Ferrero Rocher different from virtually every other chocolate on the market. A Ferrero Rocher is not simply a chocolate with something inside it. It is a 5-layer system, and each layer has a specific job. At the center is a whole roasted hazelnut. Around that is the smooth hazelnut chocolate filling. Encasing both is a thin, precisely manufactured spherical wafer shell. Outside the wafer shell is another application of the smooth filling. And on the outermost surface is a coating of milk chocolate combined with finely chopped roasted hazelnuts, 5 layers, 5 separate manufacturing inputs, all assembled in sequence around a center that must remain exactly positioned throughout. Owing the wafer shell, the 3rd layer from the outside, the structural housing at the heart of the product, is manufactured in its own dedicated production area, separately from everything else, and it begins with a batter. The wafer batter is a liquid mixture of wheat flour, sugar, vegetable oil, and water, mixed to a precise consistency and held at a controlled temperature before use. It is fed into a wafer baking line, a series of heated molds, each shaped like a hemisphere, that open and close in a continuous cycle. When a mold opens, a measured volume of batter is deposited into the lower hemisphere. The upper hemisphere descends, the mold closes, and pressure and heat act on the batter simultaneously. In just a few seconds, the moisture in the batter converts to steam. The steam expands through the thin layer of batter, and the result is a light, crisp, curved wafer, half with a hollow interior. The mold opens, the half is removed, and the process repeats continuously, producing a constant stream of matching curved wafer pieces, moving forward on a conveyor. What happens next is unexpected because the 2 wafer halves do not come together around an empty space. Before the shell closes, the assembly process introduces both of the center components in sequence. The bottom wafer hemisphere moves into position beneath a filling depositor, a nozzle connected directly to the temperature-controlled tanks holding the smooth hazelnut chocolate paste. A precise measured volume of filling is piped into the hollow of the lower wafer half. The quantity is controlled exactly, enough to occupy the correct volume of the interior space, leaving room for the nut. Then, for a single whole roasted hazelnut, one of the individually selected size-sorted nuts set aside earlier, is placed directly into the filling deposit, pressing gently into the paste so that it is held at the center of the sphere. The upper wafer half descends. The 2 halves meet at their equators. The seam is sealed with a small application of the filling material, acting as an adhesive between the 2 curved edges. What exists now is a complete, sealed, spherical wafer shell, thin as a biscuit, light as a hollow ball, with smooth hazelnut filling inside and a whole roasted hazelnut sitting exactly at its center. This core piece is the foundation of everything that follows, and from this point forward, every remaining step in the process adds a layer to the outside of it. The sealed wafer spheres travel on a conveyor into the first external coating stage, and the machine responsible for this step is called an enrober. The wafer spheres pass through the enrober on a wire mesh conveyor belt, and above them a controlled curtain of the smooth hazelnut chocolate filling flows continuously downward. As each sphere passes beneath this curtain, the filling flows over and around it, coating the entire surface of the wafer shell in a thin, even layer. The flow rate, the temperature of the filling, and the speed of the conveyor are all coordinated so that the coating thickness is consistent across every piece. The excess filling falls through the wire mesh below and is recovered, recirculated, and returned to the enrober. Nothing is wasted at this stage. The newly coated spheres exit the enrober with a smooth, a uniform layer of filling on their surfaces, glossy and soft, the underlying wafer shape still clearly visible through the thin coating. But the surface is still smooth at this point. And Ferrero Rocher is not supposed to be smooth on the outside. The next machine changes that completely. From the enrober, the coated spheres move immediately into the nut coating drum, a large, slowly rotating vessel where finely chopped roasted hazelnuts and a final application of milk chocolate are introduced together. As the drum rotates, the spheres tumble slowly through the mixture of chopped nuts and chocolate. The still soft outer surface of the filling layer grabs the nut pieces and holds them. The chocolate helps bind the nuts to the surface and fills the gaps between the irregular nut fragments. As the drum continues to rotate, the coating builds, layers of chopped nut and chocolate accumulating on the surface of each sphere, pressing together, creating the rough, uneven, golden brown exterior that is the most visually distinctive feature of the finished product. The irregularity is real and uncontrolled. Different nuts, different sizes, pressing into the surface at different angles, which means that across 3 billion pieces, no two surfaces are ever identical. The machine produces the randomness intentionally, because that randomness is exactly what the product is supposed to look like. When the spheres exit the coating drum, they are close to their finished form, but still soft, still warm, still in need of the stage that locks every layer permanently in place. The coated chocolates enter a cooling tunnel, a long, enclosed conveyor passage where temperature-controlled air flows over the pieces as they travel from entry to exit. The tunnel is divided into zones, each maintained at a slightly different temperature, so that the cooling happens progressively rather than all at once. This gradient cooling approach matters because chocolate is sensitive to how quickly it changes temperature. Rapid cooling causes the cocoa butter inside the chocolate to crystallize in unstable forms, which leads to surface blooming, the white, chalky discoloration that appears on chocolate stored incorrectly. Slow, controlled cooling encourages the cocoa butter to form stable crystals, which gives the chocolate a clean surface, a firm texture, and the slight snap that good chocolate is known for. By the time each piece reaches the end of the cooling tunnel, the outer nut and chocolate layer is fully set. The filling layer beneath it is firm. The wafer shell inside is intact. The whole hazelnut at the center is held exactly in position. Every layer is bonded to the layer around it. The architecture is complete and stable. What comes out of the cooling tunnel is, structurally, a finished Ferrero Rocher, but it still needs to be checked before it can move to wrapping. The inspection system positioned at the exit of the cooling tunnel uses an array of cameras and weight sensors to evaluate every piece that passes through. The cameras capture each chocolate from multiple angles. Even the system analyzes the images for surface coverage, checking whether the nut coating extends uniformly across the entire surface without bare patches or gaps where the smooth filling layer beneath might show through. The weight sensors verify that each piece falls within the accepted gram range for a finished unit. A piece that is too light likely has a thin coating. A piece that is too heavy may have an excess that affects the proportions. Both are removed from the line automatically, a precisely timed mechanical rejection that happens without slowing the conveyor or interrupting the flow of pieces behind it. Rejected pieces are directed to a recovery channel where salvageable material is separated and reintroduced into the appropriate earlier stage of the process. Pieces that pass continue forward to the wrapping machines. The wrapping stage is the fastest and most mechanically intricate part of the entire line, and watching it run at full production speed is one of the more remarkable things a factory floor has to offer. Each chocolate arrives at the wrapping station carried on a timed conveyor that delivers pieces at intervals precisely matched to the speed of the wrapping mechanism. The foil used for Ferrero Rocher wrapping is a thin, gold-toned metallic material, not actual gold, but an aluminum-based foil laminate with a surface finish that produces the warm, bright color associated with the brand. It is fed from large rolls into the wrapping machine, where it is cut to exact dimensions for each piece. The chocolate is placed onto the cut foil sheet. Then the machine's folding heads move through a rapid sequence of mechanical gestures, gathering the foil up around the sides of the sphere, pleating the excess material at the top into tight, even folds, and pressing the gathered foil into the characteristic crown shape that sits at the apex of every wrapped piece. The entire sequence, placement, gather, fold, crimp, complete, takes under 1 second. The line does not pause between pieces. There is no gap, no hesitation, no manual adjustment. The mechanism cycles continuously, and the wrapped pieces move off the exit conveyor in a steady, unbroken stream. Immediately after foiling, each piece receives its paper cup. The fluted brown paper cup, the small, circular cradle that every Ferrero Rocher sits in, is applied to the base of the wrapped chocolate by a separate mechanism positioned directly after the foil wrapping station. The cup is preformed and fed from a magazine into the applicator, which places it precisely beneath each passing piece. A small adhesive contact secures the cup to the foil at the base. Then a branded label, the small circular sticker, that presses the gathered foil crown flat and carries the Ferrero Rocher name, is applied over the top of the wrapped piece by a label applicator further along the same line. At this point, the individual unit is complete. It looks exactly as it does on a shelf or inside a gift box. Gold foil, fluted cup, label on top, the rough texture of the nut coating visible through the tight wrapped foil. In the whole hazelnut hidden at the center. From the individual wrapping line, the pieces move into the packaging assembly area, where they are grouped into the retail formats that reach consumers. The 3-piece boxes, small, often bought as single gifts, are filled first by a grouping mechanism that collects individual pieces into sets of 3 and presents them to a box loading system. The 16-piece boxes require a slightly larger grouping and placement sequence. The large transparent spherical gift containers, the ones that hold 24 pieces arranged in visible rows and appear in enormous quantities during the holiday shopping season, use a combination of automated placement and orientation control to ensure the pieces are positioned with the labeled tops facing outward through the clear plastic. The visual presentation inside the transparent packaging is not incidental to the product. The rows of gold-wrapped spheres seen through clear plastic are a significant part of why the product reads as premium on a retail shelf. The packaging is designed to make the product visible, and the placement process is designed to make that visibility consistent. Filled packages move through heat sealing stations where the packaging is closed, then through label application where the outer product information, weight declarations, ingredient lists, and barcodes are applied. Complete retail units are transferred to case packing machines that group them into outer shipping cases, the cardboard boxes that carry the product through the distribution system. Cases are sealed, coated with production batch information and date stamps, and moved by conveyor to palletizing systems where robotic arms stack them onto wooden pallets in precise configurations optimized for stability during transport and efficient use of truck and warehouse space. Completed pallets are wrapped in stretch film, labeled and transferred by forklift into refrigerated staging areas where temperature is maintained to protect the chocolate through the first stages of its journey out of the factory. The distribution network that carries finished product from Ferrero's production facilities to retail shelves operates in more than 170 countries. Cold chain management continues through regional distribution centers and final delivery logistics, ensuring that the temperature sensitivity of the chocolate is respected all the way to the point of sale. The scale of the logistics infrastructure required to move 3 billion individual chocolates per year, from a factory in Piedmont, Italy, and additional facilities in other countries, to retail locations across 6 continents, is itself a remarkable operational achievement. But from the perspective of the production line, the pallet leaving the factory floor is the final moment. Everything after that is delivery. What began as a raw hazelnut arriving at a receiving bay has traveled through roasting drums, grinding mills, wafer baking molds, filling depositors, enrobing curtains, nut coating drums, cooling tunnels, inspection cameras, foil wrapping heads, cup applicators, label stations, case packers, and robotic palletizers, and emerged as a finished, wrapped, packaged, shelf-ready Ferrero Rocher. 5 layers, 1 whole hazelnut at the center, 12.5 grams, gold foil, brown cup, label on top, exactly the same as every other one, 8 million times a day. That is the complete production journey, from the orchard to the wrapper. Every stage in sequence, nothing skipped and nothing added that isn't there. A process of genuine precision, running continuously, producing something that most people pick up, unwrap, and eat in about 4 seconds without a second thought. If you found this worth watching, a like takes 1 second, and it helps more than you might think. Subscribe if you want more factory documentaries like this. There's no shortage of processes worth seeing, and drop a comment below with the product you want covered next. The answer might surprise you.